Hello, today we are starting chapter 12, which is our last chapter of the year. We are finally graduating from two-dimensional shapes onto three-dimensional shapes. In chapter 12, we're going to be looking at surface area and volume of lots of different shapes. Today we're talking about prisms, but later we'll look at cylinders, cones, spheres, pyramids, and other shapes. When we start talking about three-dimensional shapes, most of what we're going to look at are called polyhedrons. A polyhedron is a closed three-dimensional shape that's made up of all flat sides. So our prisms, our pyramids are polyhedrons, but things like cones and spheres are not polyhedrons because they have curved surfaces. When you look at a polyhedron, like a prism or like the box on the page here, polyhedrons have different parts. Each of the sides are called faces. So if you look at this box here, each one of these 6 different sides are the faces of the box. So here's one face on the right side, another one on the left, front, back, top, and bottom of the box. An edge is where the two faces intersect. So here's one edge of the box where the right and the front sides meet up. And then a vertex is a point where 3 or more edges intersect. So one of the vertices here would be this point where the edges meet up. Today's lesson is about prisms. Prisms are polyhedrons that have to have 2 parallel congruent sides that must be polygons. There are lots of different types of prisms which are named according to the sides that are called their bases. Those are the 2 parallel sides that are not rectangles, if that's an option. So the real name for a box is actually a rectangular prism. And that's because if you choose 2 parallel congruent sides, like the right and the left sides of this box, they are rectangles. For a rectangular prism, any 2 sides can be the bases, top and bottom, or the left and the right, or the front and the back. It just depends on how you look at the figure. But for something like the second picture, there are only 2 parallel congruent sides. In this shape that sort of looks like a tent, they would be the doors of the tent, the front and the back here. Because those 2 sides are triangles, this is called a triangular prism. And in this third shape here, again, it's the front and the back of the picture. These 2 parallel congruent sides are pentagons. So this is a pentagonal prism. Besides the different types of prisms according to their bases, we also have regular prisms, and they are prisms where the bases are regular polygons. So remember, that means all sides, all angles congruent. When we talk about the faces of a polygon, we have lateral faces and then those bases. So our bases are the 2 parallel congruent sides, but all of the other sides of the shape are called the lateral faces. Lateral edges are the intersection of our lateral faces. So if you take a look at this hexagonal prism in the picture, it shows you there are 6 lateral faces. They are the 6 sides that go around the shape this way. Let me see if I can try to identify at least a few of them for you. Here are 3 of the lateral faces, and then there are another 3 on the back side of the picture. The hexagons are the bases in this picture, the top and the bottom. And then our lateral faces are where the lateral sides, the lateral edges intersect. So here's 1, 2, 3, 4, 5, 6 lateral edges in this picture. If a prism is a right prism, then the lateral edges are going to be perpendicular to the bases. So when you take a look at any one of those lateral edges, notice that it's perpendicular to both the bases, top and bottom. But we also have something called an oblique prism. In an oblique prism, the lateral edges are not perpendicular to the base. Instead of something perpendicular to the base would look like this. Regardless of whether we have a right or an oblique prism, all of our calculations are still going to be the same. So in the first part of today's lesson, we're going to look at the lateral area and surface areas of prisms. The lateral area is the sum of the area of all of the lateral faces. Surface area is the total area of your figure. And actually, I think that a cylinder is the easiest shape to think about lateral area versus surface area. So imagine something like a soup can. If you were asked to figure out how much paper you need in order to create the label on your soup can, you would be talking about lateral area. Covers only those lateral sides. But if I asked you how much aluminum you would need to create the entire can, well, then you want to cover the top of the can, the bottom of the can, and the entire way around the outside. Hold on to all the soup. That would be your surface area. So lateral area does not include the bases. Surface area is the entire shape. There are two formulas for a prism for area. One is for lateral area, the other for surface. So to find the lateral area of a prism, you multiply capital P times lowercase h. Capital P represents the perimeter of one base. H is the height of the shape. Of course, height is still perpendicular to the base. Surface area takes your lateral area, since you've already calculated most of the shape, and then adds on your two bases. So surface area is capital L plus 2 times capital B, where B is the area of a base. You may see in some of my notes or homework assignments, surface area is sometimes denoted by the letter T, and that's because it can be referred to as the total area. So you may see surface area as S, but you also may see it as the capital letter T. Okay, if you flip over to the back, let's take a look at two examples for lateral and surface area. So in question number 1, here we have a triangular prism. It's a right triangular prism because our lateral edges are perpendicular to the bases. In this picture, the bases are the top and the bottom of the shape, these two triangles. In order to find the surface area, to find the lateral area first, we are going to use our formula, capital P times lowercase h. Capital P is the perimeter of one base. So if I look at the base that's at the top here, I know two of the sides, 15 and 8, but of course we need to know the length of the last side. Since this is a right triangle, we can use Pythagorean theorem. So 15 squared plus 8 squared equals, let's call the hypotenuse c squared. So that's 64 and 225, or 289 equals c squared. So the hypotenuse is 17. So to find the perimeter of one base, we'll add up 15, 8, and 17 for a perimeter of 40 units. That then gets multiplied by the height of our three-dimensional shape, the height of our prism. So height has to be perpendicular to the base, so it'll run back and forth between the two bases. So the height of this prism is 21 units. When we multiply the perimeter and the height, our lateral area is 840. And here they don't give us units, but you still have to put something. So let's call this units squared. Of course, the lateral and surface area are both measured in square units because they are types of area. Okay, to find the surface area, our formula for the surface area of a prism is the lateral area plus 2 times the area of a base. So we've already calculated the area of all of the space around our picture for these sides, not including the base. So we've got these 3 sides of our prism. To find the surface area, we're essentially adding the top and the bottom back on. So our lateral area, we figured out already, is 840 plus 2 times. To find the area of the base, here our base is a triangle. So if I use this triangle again, to find its area, I multiply 1/2 times the base of the triangle, which is 8, times the height of the triangle, 15. When we multiply out the second part, 2 times 1/2 is just 1. 8 times 15 is 120. So if we add 840 and 120, our total surface area is 960 square units. Okay, in question number 2, we have what's called a trapezoidal prism. So here the bases are the front and the back of this figure, these 2 trapezoids. If we start first by finding our lateral area for any prism, perimeter, the base, times the height. So if I look at our base, the trapezoid here, we only have 2 of the sides, but we're given the 60-degree angle on the side. I'm going to redraw just that trapezoidal base so that we can see it better. So here the bottom is 11, top is 7, and the 60-degree angle is this angle here. To find the perimeter, we of course need all the sides of this trapezoid. So I'm going to create a rectangle on the right side and a little triangle on the left side. If the entire bottom of the trapezoid is 11, the top is 7, when I subtract them, the bottom of the triangle is 4 units long. Now I'm going to focus in on the 30, 60, 90 triangle that I've created over on the left side of this picture. So in a 30, 60, 90, the short leg is 4 units long. So the hypotenuse, which is the 2n side, must be 8 units. And the long leg, which is n root 3, must be 4 root 3. Because the shape on the right side is a rectangle, if my dotted line is 4 root 3, the right side of the trapezoid is also 4 root 3 units. So now I can find the perimeter of this trapezoidal base. The left side is 8, top is 7, right side is 4 root 3, and bottom is 11. That makes the perimeter about 32.93. And this gets multiplied by the height of our shape. Remember, the height must always be perpendicular to the base, has to stick out between the 2 bases for a prism, or run back and forth between the 2 bases. So for this figure, our height is going to be 10. So our lateral area ends up at about 329.3. And again, we don't have units, so we'll put units squared. Okay, to find our surface area, we take our lateral area and add on the 2 bases. So our lateral area was 329.3. And now we need to add on those two trapezoidal bases. So area of a trapezoid, 1/2 times the height of the trapezoid. So here the height of the trapezoid was 4√3 times base 1 plus base 2. So that would be 7 and 11. Okay, if I multiply out 2 times b, the two bases together have a total area of 124.7, which makes our total surface area 454. Now that's rounded, so I'm putting the 0.0 square units. Okay, question number 3. Ava and Casey are painting the walls and the ceiling of their living room. The room is 20 feet long, 15 feet wide, and 12 feet high. Find the surface area to be painted. So let's get a rough sketch of their room. And we're going to assume that this is a typical rectangular room. It is 20 feet long, 15 feet wide, and 12-foot ceilings. Okay, they want to paint all 4 walls and the ceiling, but not paint the floor. So in order to figure out how much surface needs to be painted, we're going to start by calculating the lateral area. So in the context of this question, the lateral area would tell me the total area for the 4 walls of the room. Okay, but then I also have to paint the ceiling. So in order to add on our ceiling at the end, we're going to then add on only one base, the top, the ceiling of the picture. So lateral area, perimeter of the base, times the height. So for our base, or the bottom of this shape, perimeter is 2 times 20 and 2 times 15. The height of the room is 12 feet. And then capital B, area of the base, is our rectangular base, so 20 times 15. And when I put all this into the calculator, perimeter of the base was 70 units times 12. So lateral area of 840. And then when you multiply 20 times 15, should be 300. So altogether, they need to paint 1,140 square feet. Okay, the last part of the lesson for today is on the volume of prisms. So volume, of course, tells you the amount of space that's enclosed inside of a three-dimensional picture. If we go back to our soup can example, our lateral area was just for the label of the soup can. Surface area was the amount of aluminum required to make the entire can. Volume would tell you how much soup fits inside, how much sand you need in order to fill a sandbox, how much water it takes to fill up an entire pool, etc. For a prism, the formula for volume is area of the base times the height. So here's our capital B again, area of only one of the bases, times height, the height of the prism. So we have 2 examples here. The first one is a triangular prism. So if we need the volume of this triangular prism, we have to start by figuring out the area of one of the bases and then multiply it by the height. So if I focus on one of the triangular bases, so I'll just look at this front triangle here. In order to find the area of a triangle, we have to multiply 1/2 base times height. if I redraw this picture, this triangular base is isosceles. They've shown that both of the sides here are 13 feet. So when I draw a height for an isosceles triangle, it cuts the base in half. So if I look at just the right triangle I create with our height, the bottom of the right triangle is 5 units. So I can find the height, let's label that h, using Pythagorean theorem. So h squared plus 5 squared equals 13 squared. H squared plus 25 equals 169. So that h squared is 144. And the height of the triangle is 12. All right, to go back to our volume formula. So volume is area of our base, so 1/2 times the base of our triangle, which is 10, times the height of 12 that we just found, times this height is the height of our three-dimensional prism. So the height of this triangular prism is 19 feet. And when we multiply all of this together, the volume here, 1,140 cubic feet. Volume is, of course, always a cubic measurement. And for one final question, we have a hexagonal prism. So the bases in this picture are the top and the bottom, which are each hexagons. To find the volume of this prism, again, we're going to multiply area of the base times the height of the prism. To find the area of the hexagonal base, we have to use our formula for a regular polygon. So that's 1/2 perimeter times apothem. So we have 1/2 times the perimeter of the hexagon. There are 6 sides. They are each 6 units. So perimeter is 36 times. To find the apothem, I'm going to draw in that little right triangle that we use each time. So inside of our hexagon, this small right triangle has an angle up at the top here of 30 degrees. That's found again by taking 360 divided by 6 sides and then divided by 2 because we're only looking at a half of a side. That means this angle is 60 degrees. And if the entire side of the hexagon is 6, half of that would be 3. The apothem, which is the long leg in this 30, 60, 90, is then 3 root 3 units long. Okay, when I multiply that out, the area of the hexagon should be about 93.53. And to find the volume of the prism, we then multiply that by the height, perpendicular to the two bases, which here is 10 centimeters. And that makes our volume about 935.3 cubic centimeters. Please make sure you complete the homework for this section. Show all of your work in order to get full credit.